Hello, I'm Andrew Eckford from York University. Communication is everywhere in nature, from intercellular signal transduction to birds singing and wolves howling. So it is natural to wonder how our mathematical toolbox for understanding communication, especially Shannon's information theory, might be used to understand these natural systems. There are two apparent obstacles to applying information theory to biology. The first is that modern communication systems use extremely complicated encoding and decoding algorithms to achieve the Shannon bounds. How could cells implement algorithms like this? The second is that the meaning of the message is important to a biological system. For example, this image is rich with visual information, but only one bit is important to an organism: the presence or absence of a predator. Yet Shannon tells us that meaning or semantics are irrelevant to information theory. We can bring these threads together using a technique known as Kelly betting. Kelly was a student of Shannon's and applied information theory to horse racing in the presence of noisy information. He showed that a gambler offered fair odds who wanted to maximize the log rate of growth of their winnings could use bet hedging to achieve a log rate of growth equal to the mutual information between the race outcome and the noisy information. This solves both problems we mentioned. First, it requires no complicated encoding or decoding. Second, the semantics of the information, that is the effect on the gambler's fortune, is explicitly maximized. Organisms, too, make bets based on noisy information to maximize not their fortune, but their evolutionary fitness. For example, a seed needs to decide when to germinate. Too early and it might be killed by frost, too late and it might not have enough time to produce seeds. There are many examples of bet hedging in nature, and in this talk we will consider how to use information theory to understand questions of sensory information and biological fitness. Thank you for listening, and I'm looking forward to seeing you in St. John's.